This is lesson 4.2. In this lesson, we will be working with the standard form of the quadratic function. Our first objective is to find the vertex, the axis of symmetry, maximum or minimum value, and the range from a standard form equation. We've already done this with vertex form. So here is a standard form equation, y equals 2x squared plus 8x minus 2. If we want to find the vertex, the easiest way would be to graph this. So if you have a graphing calculator, you can put the equation into your graphing calculator. If you don't, you can go to GeoGebra. So if you type in geogebra.org/webstart, put in the /webstart, that'll be the quickest way to get it to download, and then you will see a screen like this. When your screen comes up, you click on this web start button and you'll get something that looks like this. Okay, down here in the bottom where it says input, this is where you're going to type your equation. So we want to put in our equation y equals 2x squared plus 8x minus 2. If you press enter, it will graph your function. So then, if we click on this crossbar thing, we can move the graph around so we can see it better. So here is the vertex. If we want to know the name of that point, we can click on it, and it tells us that we have a point at -2, -10. So the vertex is at -2, -10. And then, of course, the axis of symmetry would run through that. So let's go back to our lesson. So we know the vertex is at -2, -10. Since the vertex is at -2, -10, then the axis of symmetry has to run through the x value, so the axis of symmetry would be at -2. The maximum or minimum, we know it was a minimum value because we saw it on the graph. The minimum value will be equal to the y value in the vertex, so that's -10, and the range, of course, goes to the y values. So our range would be all real numbers where y is greater than or equal to -10. Okay, so that seems simple enough. You just graph it and you look at the graph. So here's another example. So if we go into GeoGebra and graph it, let's see what happens. Okay, so in GeoGebra, we'll put in our equation. -3x squared minus 4x plus 6. Press enter and we get a graph. And let's find the top of that graph. There it is. We'll put a point on here. And the point is not a good one. Maybe it's in the wrong spot. Maybe we should move our point around. No, that's not helping. So sometimes the vertex is not at an obvious location, so we have to have a plan B. This is plan B. In order to find the vertex, you can use this formula, -b over 2a. So what are b and a, you may ask? Well, in your standard form equation, a is the leading coefficient, b is the coefficient on the x term, and then c is the constant term at the end. So if we wanted to find the vertex to our previous question, we would use the formula -b over 2a. So that would be a -4, because this is b. Divide that by 2 times -3, because this is a. So that would give us 4 over -6, which is a -2/3. So that's not the whole vertex, that's just the axis of symmetry. So we just found out the axis of symmetry is at x equals negative 2/3. So how do we get the y value? To get the y value, you're going to plug 2/3 back into the equation. So we'll have negative 3 times negative 2/3 squared minus 4 times negative 2/3 plus 6. And we have to calculate this. So you can see all the math that I've done here. And it turns out y equals 22/3. So the vertex would be at negative 2/3 and 22/3, which is similar to what we saw on GeoGebra. The point A is at negative 0.66, which is negative 2/3, and 7.33 is 22/3. Okay, so we want to graph this function. In order to graph the function, the first thing we should do is find the vertex. To do that, we're going to use our formula, x equals negative b over 2a. So we're going to have negative 2 over 2 times 1, which gives us negative 1. That's the axis of symmetry. To find the y value, we're going to plug that negative 1 in, and we get negative 1 squared is 1. 2 times negative 1 is negative 2 plus 3. So that gives us negative 1 plus 3 would be 2. So we have a vertex at 2, or at negative 1, 2. There's a vertex. So now to get additional points, we will have to make an xy table. We know we have a vertex at negative 1, 2. So we should pick points that surround this. So things nearby would be 0 and 1. And then we'll have symmetry at negative 2, negative 3. So if we plug a 0 in, we get 0 squared plus 2 times 0 is 0, plus 3 is 3. Plug a 1 in, and we'll get 1 plus 2 plus 3 is 6. And because of symmetry, we know we'll have matching points on the other side. So we have 0, 3, and 1, 6, and our symmetric points. And there's the graph. Here's one for you to try. Press pause while you try it, plus press play when you're ready to continue. The last thing we're going to do here is we're going to convert our standard form equation to a vertex form equation. To do that, we have to find the vertex. So using our formula, x equals negative b over 2a, we're going to have negative 10 over 2 times 2. So that gives us negative 10 fourths, which is negative 5 halves. Then we're going to substitute 5 halves in and calculate y. And this comes out to negative 11 halves. So we know the vertex is at negative 5 halves, negative 11 halves. So if we're going to convert to vertex form, we will substitute into vertex form equation, where the vertex is h and k, and the leading coefficient is a. It's a in both forms. So we get y equals 2 times x minus a negative 5 halves would be plus 5 halves minus 11 halves. And there's the vertex form. Here is one for you to try, and that's it for lesson 4.2.